Okay. All right. Well, I'm recording now, so let's begin. Shh, shh, shh. This test, I will tell you specifically, is on the following lessons: 16.1, 16.4, 17.1, 17.3, and 17.4. So it's only on 5 lessons. Okay? So there's only 5 lessons on this test. Starting with lesson 16.1, dilations. Now you may remember that a dilation creates a similar shape. And a similar shape has the same size, has the same shape, but not the same size. So of these figures, which one is the dilated shape? Sorry, I gotta bring this back up again. Once I rotate it, it's hard to get back. Okay, so you can turn to 16.1 if you'd like in your books, or you can just look up here on the board, on the screen. Which of these is the dilated shape, the smaller or the larger?
The larger.
How can you tell?
Because it has the apostrophe.
It has the apostrophes, which are called the primes. The primes. Good. So it's got the primes. Okay? So I can always tell this is the dilated shape because it's got the apostrophes of primes. Now, if I ask you for the scale factor, so the scale factor, remember that's always going to be the size of the dilated shape over the original. So how can I figure out the scale factor here? Well, I could take a look and say, well, the dilated shape, this side is 1, 2, 3, 4, 5, 6. That's 6. And this one is 1, 2, 3. So 3, so the scale factor is 2. Scale factor is 2. Simple as that. Now, in a lot of ways, what else do I know about a shape when it's dilated? Similar shapes, that the scale factor has to be the same for all the sides. You guys remember that? Scale factor has to be the same for all the sides. But in terms of dilations, that's basically the long and short of it, what I just showed you. Next, 16.4. Angle-angle similarity of triangles. You have to know this. If I take a look at these two triangles, I can tell you without a doubt that they are similar. How can I tell you without a doubt?
It's got the 2 lines, so it's angles. Yeah.
It's got 2 pairs of angles that are congruent. If I have 2 triangles that have 2 pairs of congruent angles, such as this, then I know that the triangles are similar. Now, what would the similarity statement be? Triangle A, B, C is similar to triangle. I have to make sure I put it in the right order. I start with A, which is the red angle, so I start with P. Then I go to B, which isn't marked, so I go to Q, which isn't marked. Then I go to C, which is blue, so I go to R, which is blue. I have to put them in the correct order, otherwise it's incorrect. All right? So I know, therefore, that these 2 triangles are similar, which means they're the same shape, yet not necessarily the same size. Now, I'm asking you in this question for the length of QR. So how do I find QR? That's the question. Well, I know the ratios between corresponding sides are the same for two similar triangles. What does that mean? Well, I compare the side between the red and the blue angle, which is 2.0, over the one here in this triangle, which is 1.6. The ratio between those two is the same as the ratio between these two sides. So it would be 1.2 over QR. See this? Now, people often say, how do I know which triangle goes on top and which is on the bottom? Well, it doesn't matter as long as you're consistent. So in this case, I put the triangle on the left, 2 and 1.2 on the top, and the triangle on the right, 1.6 and QR on the bottom. Okay, how do I solve for QR? Bam, just do it. Have bravery. 2QR equals 1.2 times 1.6. Then I divide by 2 to solve. And I get QR equals 0.96. I'll repeat, you guys will need a calculator for this test. If you don't have one, then you can still do everything, except for there will, can't remember exactly, I also haven't written the entire test yet, but there will be some square roots which you're not going to be able to do by hand. You're just not. Unless you're just a crazy genius, which maybe you are. Okay. So QR is 0.96. You're done. Does that make sense? All right. Now, you also might be given something like this, where it says, determine whether or not these triangles are similar. So if they are similar, then I know the corresponding sides are proportional, right? Which means the ratio between them is the same, right? So the question is, what do I compare to what? So I'd compare 16 to which side here? Why 9?
Because 9 is good.
Because 9 is good. What type of triangle is this? Isosceles. And this one? Isosceles, right. So I'm going to compare 16 to 16 because there's 2 of them, so the 9 and 9, right? Okay, that's critical thinking skills. You guys might not realize it, but you're like, yeah, 16 to 9. Obviously, you compare those two. How? Critically think. How do I know that for sure? That's the critical thinking skills that I'm hoping to engender with this test. 16 over 9 equals 5 over 3. Now, what happens if these ratios are the same? What do I know about these triangles? They're similar. And if they're not the same, then they're not similar. So let's try it. 16 over 9 is 1.7 repeating. 3 is 1.6 repeating. Are the ratios the same? No. So are they similar? They're close, but not similar. Any questions? Okay. Now, something like this question would be a good question to do. Oh, by the way, there will be word questions on this test. There will be word questions without pictures. Guess what you should do?
Draw a picture.
Draw a picture. Okay. So let's take a look at this. What is the height of the image to the nearest tenth? Okay. Well, we know this is 14, and this is 4 feet 6 inches, which is 4 feet is 48 inches. What's the problem here? What's the problem here? It's different units, right? So I got to get it all in the same units, otherwise it's going to be messy. So 4 feet is 48 inches plus 6 is 54 inches. 5 feet is 60 inches plus 5 is 65 inches. Okay, so here's a triangle. All right. Here's a triangle. Okay. And I know this is 54 inches from here to here, and this is 65. Okay, this is 15 and asked about the height. Okay, well, I think I can do that. The height corresponds to the height of this player, right? Does this make sense? 65 inches. And the distance here, 15, corresponds to the distance here, 54. You see? Now here's the deal. If you can't just even set that up, you're going to have an issue, right? If you can't figure out, okay, wait a second, it's this distance compared to this distance is the same as this height to this height. The ratios are the same. Does that make sense? You have to be able to see it, critically think about it, and then create the ratios. Once you've done that, I mean, solving for that, you've got a calculator. Like, there's no issue in solving for h once you got here, right? So the thing is setting them up. There's not a ton of algebra. You're not using quadratic formula. You're not doing a ton of stuff. You just have to be able to critically think about the problem and set it up. Okay? So that ends up being 65 times 15 divided by 54, which is 18. Approximately 18 inches. It says to the nearest inch. So your inches are your units, so 18 inches. Okay, good. Now, moving on. That was module 16. Moving on to module 17. The triangle proportionality theorem. What does the triangle proportionality theorem say? The triangle proportionality theorem says if I've got a triangle and it's intersected with a line that's parallel to one of the sides, then it cuts these sides proportionally. What does that mean? You guys might remember if I kind of used the colors that I used. This is 17.1. Remember, it's like the green and the yellow. Do you guys remember this? The green over the yellow is equal to the green over the yellow, right? So it divides the sides proportionally. So the ratio of the green to the yellow is the same as the green to the yellow, right? Okay. So what could something like this look like? What could something like this look like? Well, it could look like this. Okay. It says find KL. So here you go. Green, green, yellow, yellow. Nice. Okay, so 4 over 6 is equal to KL over 8. Simple as that. If you do not know how to use the triangle proportionality theorem, you will look at this question and be like, it's hard. So it's harder to do if you try and just use similar triangles. So you got to use this. Multiply by 8, but if you know how to use it, that's really simple. Becomes 8 times 4 is 32, divided by 6 is 5.3 repeating. Okay. Any questions on this? Yes. Oh yeah. I'm recording right now, so this video will be going up. Okay. Next, this one talks about XZ. Guys, if you have to bring in colored pencils and mark things in color, I am so happy to allow you to do that. There's no reason not to. Okay, it asks for xz. Okay, well I know xz over 30 is equal to xy over 18. But do I know xy? This is 30, so how do I find xy? What's xy?
You gotta subtract 18 from
Yeah.
30.
30, I do 30 minus 18 equals 12. So that's that. So equals 12 over 18. You see how they just added a little bit of an element of like, ooh, I don't know how to do this, right? So then I just multiply by 30.
600.
72?
That's what I said.
No? No, that's it's like 12. No, 20. Sorry. 20. Oh, it happens. Okay, x equals 20. All right? You see how this one was different than the last one? That's what I'm talking about. Like, you got to be able to look at it and be like, oh, I just have to get that side. If you're not able to critically think about it, then you're going to be like, oh, wait, 18 over 30? How do I use that? Okay? Could also look, I mean, this is almost the exact same. In fact, that is the exact same. So I'm not going to do it. Number 5 is very similar. Okay? What's a good example of a question like this that I could do? It's right here, number 10. Okay? Let's take a look at number 10. On the map, 1st Street and 2nd Street are parallel. What is the distance from City Hall to 2nd Street along Cedar Road? Okay, here's City Hall. These two lines are parallel, so here's green, and here's my yellow, and my yellow. Bam. Okay? It's asking the distance from City Hall to 2nd Street along Cedar Road. So that's this distance right here. Well, I don't know. I know this distance, and this distance. I don't know this distance. If I can get this distance right here, I'll call it x. If I can get that distance x, then I just add it to 2.4. You see? And then I solve. So I get x over 2.4 equals 2.1 over 2.8. Multiply both sides by 2.4 and then solve. Is 1.8. So, careful. Did I get my answer? No. The answer is 1.8 plus 2.4, which equals 4.2. That is my final answer. Okay, so that's a good example. I'm going to do one more example from the section. This one right here. Okay. So again, has horizontal siding that's parallel to the base. Okay, cool. So I've got my parallel lines. It says find LM. Well, I've got these green sides. The first thing is I have to check what I have. Well, I have this side and this side. I don't have LM. That's what it's asking me to solve for. But I do have this side is 2.6. So I do green over yellow. So 11.3 over LM equals 10.4 over 2.6. I cross multiply. And I get 10.4 LM equals 11.3 times 2.6. Divide both sides by 10.4. And then I solve. LM equals 11.3 times 2.6 divided by 10.4 is 2.825. So LM is 2.825. Okay. You guys still with me? Lots of people asleep. That's nice. Couple people. Nice. Michael. No. That scarred me. I remember it. Don't.
I think it's fine.
I mean, it's okay.
I didn't want that anyways.
2.8.
That was a good thing, too.
All right. 2.825. 11.3 plus 2.825 equals 14.125. You handled that very gracefully, Michael. I might have not handled it so gracefully.
Well, because I show mercy like God shows mercy.
That's good. Don't do things like that. I don't like things like that. It makes me feel sad.
Well, I'm not sad.
That's good, Michael.
It's okay.
Okay. All right. Shh. Find MN. Find MN to the nearest tenth of a foot. Okay. Now look, this whole side is the green one. And now I'm trying to get this little bit here, this MN. Okay. So again, I've got 11.3 plus 2.825 is 14.125 over MN equals, this is 10.4 plus 2.6 is 13 over 2.2. I'm just going to solve real quick. You guys know what to do at this point. 13 times 14.125 divided by 2.2. I did something wrong. Yeah, 13. Oh no, 14.125 times 2.2 divided by 13. 2.39. So this ends up being 2.4. To the nearest tenth of the foot, it's 2.4. You guys following what I'm showing you? Look, if you need to do, if I were you, I would approach this problem on your own and try and figure it out on your own and then watch the video again and look at how I did it. Because the reality is, the actual process of doing it is simple. What's the hard part is actually finding out the ratios, and that's the critical thinking aspect of it. Okay, so that's how to use the triangle proportionality theorem. 17.3. Okay, 17.3, I'm just going to do one example in 17.3, and then I'm moving on to 17.4. So pay attention. These are the easy ones, guys. The simple ones here are these ones. Okay? This is the hard one. Did I do this in this class already? It's okay. Okay, what's the issue here? I got different units, so I got to get them all in inches. 7 times 12 is 84, plus 6 is 90 inches. 8 times 12 is 96, plus 2 is 98 inches. 6 times 12 is 72, plus 3 is 75 inches. Okay, it's asking you to solve for AD. It says AD is equal to what? Okay, well, I've got to identify, first step, listen carefully. First step is identify your triangles, okay? If you've got to bring in colored pencils, a highlighter, whatever it is, so you can highlight your triangles to identify them, then great, do it. I got my bigger triangle and my smaller triangle. I got to identify, I got to get AD, which is this distance from here to here, which is the bigger side of the red triangle right here. Okay? So I say AD is, the proportion is the ratio is comparing it to 75 inches, which is the bottom side of this triangle, the smaller triangle, equals the bigger triangle, which isn't just 90, it isn't just 98, it's 90 plus 98, which is 188, over the smaller triangle, which is 98. I multiply both sides by 75. I get AD equals 188 times 75 divided by 98 equals 143.87, or rounding it off, 144 inches. How many feet is 144 inches? Yes. Good. 12 feet. Good. Any questions on that? All right. Last but not least, 17.4. This is the homework that I just checked for you guys. Doing the geometric mean is simple. Remember, if I've got two numbers, 4 and 25, I multiply them, take the square root of 100 equals 10. This is the stuff where you're really going to need a calculator, because if you don't have one, it's going to be tough. Okay, what's the harder part? The harder part is like this stuff. I'll do number 11 first. Okay, so number 11, the numbers are messed up on the screen for whatever reason, but this should be 30 and this is 40. Okay, how do I find x? Very good. Square root of 30 times 40, which equals
34.
Very good. 34.64. The question, though, is, okay, that's just the simple way, right? I know that if I've got an altitude that's splitting up one side of a triangle, right, then this equals the square root of this times this. You guys remember that? It's like x equals the square root of a times b, if this is a and this is b, right? Does that make sense? How do I find y? I've got 34.64 now. How do I find y? What theorem? I've got a right triangle. Pythagorean. Good. 30 squared plus 34.64 squared equals y squared. Okay. Y equals the square root of this whole thing. So square root of 900 plus 1200 is 45.83. Square root of 2100. So y equals 45.83. You guys get that? Does that make sense? Yeah? So look, I would get z the same way, except it would be 40 and 34.64. I hope you guys are paying attention to this. Okay, last example. Last example. Number 10. How do I find y? Look at this, class. How do I find y? This is a right triangle, right? But I can't do it yet because I don't have this side here, you see? You see how this is flipped around?
Yeah.
Look, pay attention. I have to use the Pythagorean Theorem first. Y squared plus 25 squared equals 65 squared. I subtract, I take the square roots, I end up with y equals 60. Okay, just use Pythagorean Theorem. Now that I have this, I do this side equals the square root of this plus this. So 60 equals the square root of 25 times x. Does this make sense to you guys? Because the altitude equals the square root of this times this. So 60 equals the square root of 25x. I square both sides. I end up with 3600 equals 25x. Divide both sides by 25. And I get x equals 3600 over 25, which is 144. Now that I've got x, that's 144, I can get z using the Pythagorean Theorem. So you've got this side and that side, so that's just the hypotenuse. Does that make sense?
Yes.
Guys, you gotta make sure you study. You gotta make sure you don't just take this review as like, oh, okay, I'm good, but that you go home and study. Your test is on Monday.
Also enjoy the Sabbath.
Amen. Praise God. So you go home, make sure you do get some studying, make sure you get some rest. That's all. I will see you on Monday.